All right, guys, are there any questions over any of the assignments thus far? Any question over any of the homework assignments? Now, what we're doing today is very similar to what we did on Friday, or not Friday, Thursday. Simplest form. No radicals can have perfect nth powers as factors other than 1. No radicands can contain fractions, and no radicals can appear in the bottom of a fraction. So we need to simplify them as far as we can. Now, the two properties that we're looking at today, and we're going to be utilizing, are these here. So the first one says that if we have two things multiplied inside of a radical, we can split them up as two separate radicals. So the nth root of a times b is the same as the nth root of a times the nth root of b. Now we can also take it the other way around. We can take the two individual ones and multiply them back together. Because we can take the cubed root of 4 times the cubed root of 2. Now individually we can't take the cubed root of 4 and we can't take the cubed root of 2, but we can multiply them together and take the cubed root of 8, which is 2. Now our quotient property says if we have two things being divided, we can split them up and simplify them that way, or go the other way around. Because here 162, we can't take the fourth root of it, and we can't take the fourth root of 2, but we can combine them. Take the fourth root of 162 divided by 2. Well, 162 divided by 2 is 81, and 81, the fourth root of 81 is indeed 3. So we can simplify it once we combine it. So if we look at the first one here, the cubed root of 12 times the cubed root of 18. On the calculator, if we took the cubed root of 12, we get this decimal number. And if we took the cubed root of 18, we also get a decimal number. So individually, we cannot take the cubed root of 18 and the cubed root of 12. So what we can do is multiply them together. So we can take the cubed root of 12 times 18. Now 12 times 18 is 216. Now at this point here, we could try taking the cubed root of 216. And we get 6. Questions on how we got to this here? Now another way we can look at this is simplifying cubed roots is with a factor tree. We can factor it down and to group them so that we have our groups of 3 or 2s. Now, if we do the factor tree for this here, we take the first prime number that we can use, which is 2. 2 times 108 would give us 216. Now 108 is going to be 2 and 54. 54 is 2 and 27. Now 27 isn't divisible by 2 anymore, but it is divisible by 3. 3 and 9 is 3 and 3. So we have 3 3s and 3 2s, which means 216 is the same as 2 to the third times 3 to the third, guys. So another way we can look at this is the cubed root of 2 to the third times 3 to the third. So we're really looking at the cubed root of 2 to the third times the cubed root of 3 to the third, which is 2 times 3, which gives us 6. Any questions on this here so far? Questions on anything we've done so far? Now let's look at the next one here. The fourth root of 80 divided by the fourth root of 5. Can we take the fourth root of 5? No, 5's prime. So most likely we can't take the fourth root of 80. Now will 80 divide by 5 nicely? Yeah. So what we can do is combine these. In the fourth root of 80 divided by 5. Now what is 80 divided by 5? 80 over 5 is 16. Now we need to find out what the fourth root of 16 is. And the fourth root of 16 would be? Well, we can do a factor tree. Well, we'd have 2 and 8. 8 is 2 and 4 is. So 16 is the same as 2 to the. So the fourth root of 2 to the fourth is 2. In the calculator, we could have done the fourth root of 16 and gotten 2. Any questions on any of this here? So the next one here, the cubed root of 4 times the cubed root of 128. Well, we can't take the cubed root of 4. And most likely we're not going to be able to take the cubed root of 128. But we could multiply them together to see if we can take the cubed root of it. Now in the calculator we can do 4 times 128, which is 12. Now we can see if we can take the cubed root of 512, and it is 8. So the cubed root of 4 times the cubed root of 128 is 8. And the reason the calculator worked well for this here is because the cubed root of 512 was a nice number. Questions on any of this here? Will 192 divide by 6 nicely? So it will divide nicely, so we can put 192 over 6. We can write this as a single fraction. The fifth root of 192 over 6, which is the same thing as the fifth root of 32. Now we can do this in a calculator. We can say the fifth root of 32, which is 2. If we did a factor tree, we would see that 32 is 2 to the 5th, which still tells us that this is 2. Any questions over any of this here so far? Let's look at the next one. Write the expression in simplest form. So the cubed root of 135. $125 is 5, but we're not looking at that. We're looking at the cubed root of 135. So we get a decimal, but we want it in simplest form, simplest radical form. So we don't want a decimal answer. Now we can't just take the cubed root of 135. So what we're going to have to do is our factor tree to see how we can rewrite this as a product of primes, as numbers times themselves. So what is the smallest number that will go into 135? 5. And be 5 times. So we can say 135 divided by 5 is 27. So what number will go into 27? 3. It'd be 3 times what? And 9 is. So we have 3 3s, so we have 3 cubed times 5. So what we're wanting to do with these here is rewrite them as this prime factorization. Because what that tells us is the cubed root of 135 is the same thing as the cubed root of 3 cubed times 5. Questions on how we got to this here? Now looking at this here, we can take this and split it up into our two numbers. So we have the cubed root of 3 cubed and the cubed root of 5. What is the cubed root of 3 cubed? Cubed root of 3 cubed is? And the cubed root of 5 is? The cubed root of 5. So in simplified form, the cubed root of 135 is 3 times the cubed root of 5. And we can check this in a calculator, because we can plug in the cubed root of 135 again and get 5.1299. And we multiply it by 3 times the cubed root of 5, and we get the exact same answer. So these are the same thing. Any questions on how we simplified or wrote the cubed root of 135 in simplest form? Any questions on any of this here? Okay. We're going to move on. We're going to go to the cubed root of 500 first, and then we'll go back to the division. I will tell you this, we cannot take the cubed root of 500 and get a nice number. So we're going to need to look at the prime factorization, or our factor tree of 500. So what's one of the first prime numbers that will go into 500? 2 times 250. 250 is what? 2 times 125. Well, 2 won't go into 125, but what will? 5 and lastly 25 is? So we have 2 2s, so we can say that 500 is 2 squared times 5 to the third. Which means for us here, the cubed root of 500 is the same as the cubed root of 2 squared times 5 to the third. Now we can break this up into 2 separate radicals. So we can say the cubed root of 2 squared times the cubed root of 5 to the third. Now can we simplify the cubed root of 2 squared? Will that simplify? No, so we'll still have the cubed root. But we won't fill it back in as 2 squared, because what is 2 squared? So we have the cubed root of 4. Can we simplify the cubed root of 5 cubed? And it would be 5. So the cubed root of 500, in simplest form, is 5 times the cubed root of 4. And we do that in calculator. Cubed root of 500 is here, and we can say 5 times the cubed root of 4 and get this here. Or we could say the cubed root of 500 minus 5 times the cubed root of 4. And what do we expect this here to give us? Well, the cubed root of 500 minus 5 times cubed root of 4 should be what? 0. Because we're subtracting it from itself, it should be 0. Because if they are the exact same thing and we subtract anything from itself, we should get 0. Just a way to check it. Any questions on any of this here? And again, a lot of this here is manipulating it so that we get solutions that are in simplified form. Any questions on the single numbers before we look at quotients? First one we have here. The fifth root is 7 divided by the fifth root of 8. Will 7 and 8 divide nicely? No. All the ones we've had so far, the denominator is divided out nicely, so we don't have to do this here. Now, what we want to do first is our prime factorization of the numerator and denominator. Now, the numerator, 7 is prime. The only factors of 7 are 1 and 7, so there's nothing we can do with it there. Can we rewrite 8? 8's factor tree would be 2 and 4 is 2 and. So 8 is 2 to the third. Can I take the fifth root of 2 to the third? No, we couldn't take the fifth root of 8, and 2 to the third is just 8. So we can't simplify it there. Now, the denominator, all we have is 2, yes? How many more 2's do I need to be able to take the fifth root of it? 2, because if we had 2 more, we would have a total of 5. And we can take the fifth root. So what we're going to do is multiply top and bottom by the fifth root of 2 squared. And this works out for 2 reasons. One, when we multiply these together, the denominator, fifth root, well, 2 to the third times 2 squared, how many 2's do we have? 5, yes? So in the denominator, we have the fifth root of 2 to the fifth. And what is the fifth root of 2 to the fifth? 2. So by multiplying top and bottom by the fifth root of 2 squared, we got the fifth root of 2 to the fifth in the bottom of the fraction, which works out to be 2. But what is the fifth root of 2 squared divided by the fifth root of 2 squared? It is just 1. So we're not changing the value of this, we're just changing how it looks. Now we do need to multiply the numerator. Fifth root of 7 times 2 squared. Now we do need to multiply those two together, and I can do that in a calculator. 7 times 2 squared, which is so the fifth root of 28 over 2 is the same as the fifth root of 7 over the fifth root of 8. So the fifth root of 7 over the fifth root of 8 is this here. If we took the fifth root of 28 over 2, we get the exact same thing. And again, the reason we're doing this is because we don't want to have a radical in the bottom of a fraction. Any questions on anything we've done so far? Let's look at another one of these here. So we have the fourth root of 19 over the fourth root of 4. Can we rewrite 19 as a product of prime numbers? No. Other than just 19. because 19's prime factorization is just 1 times 19. That doesn't help us. Because if there were prime factors that worked out to be 2, say 2 to the 4th or 3 to the 4th, we'd want to put it so that we can simplify it out. Now, 4 can be rewritten as what? 2 squared, because 4 is 2 times 2, so 4 is 2 squared. Now, the reason we're doing this is to know how many 2's or what we need to multiply top and bottom by. Now, it'd be very tempting to say we want to multiply top and bottom by, say, 4 to the 3rd. Because we started out with 4 here, we can multiply it by 4 to the 3rd. And this is kind of a side note, 4th root of 4 times the 4th root of 4 to the 3rd would be the 4th root of 4 to the 4th, which is 4, yes? But really what we're doing here is this is the same as 2 squared. Because 4 is just 2 squared, and if we cube it, we're really saying we're multiplying the 4th root of 2 squared times the 4th root of 2 to the 6th. Now this would give us the 4th root of 2 to the 8th, which is 2 squared, which is indeed 4. But here, we have an extra factor of 2's. We've gone above it. We've gone beyond what we actually need. And anything that we go beyond that will actually work out to be on top as well. So, what we're going to actually multiply the top and bottom by is what? It's 4th root. So how many more 2's do we need? So how many do we have to start with on bottom? 2. And we need a multiple of what number? 4, yes? How many more? 2 more. Now, if it had been 2 to the 5th on bottom, we would need. So if we had the 4th root of 2 to the 5th, well, what's the next number after 5 that we would need? Multiple of 4 after 5 would be 8. So we would need 3 more. So, now if we multiply these here, the denominator would be the 4th root of 2 to the 4th. The numerator is going to be the 4th root of 19 times 2 squared. Well, the 4th root of 2 to the 4th is 2. Now the numerator, we have 19 times 2 squared. And 19 times 2 squared is 76. And that there is the final answer. Any questions on any of this here? Now there's one last thing that we are going to look at. One over 5 plus the square root of 3. Now to get the radicals to simplify, we have to multiply the top and bottom of this fraction by the irrational conjugate of the denominator. The irrational conjugate of the denominator. That means that we're taking the bottom of the fraction and changing the sign in the middle. So we're going to multiply the top and bottom of this by its denominator's conjugate. So we're just changing the sign in the middle. Because what we're wanting to do is is to get the denominator's radicals to simplify. And if we multiply 1 over 5 plus the square root of 3 by 5 minus the square root of 3 on top and bottom, the radicals in the bottom of the fraction are going to cancel each other out. Now we can multiply the numerator out. 1 times 5 is 5. 1 times negative square root of 3 is negative square root of 3. Because multiplying by 1 is quite nice. Now we multiply the denominator. 5 times 5 is 25. Guys, 5 times negative square root of 3 is negative 5 square root of 3. Square root of 3 times 5 is going to be plus 5 square root of 3. And square root of 3 times negative square root of 3, positive times a negative is a negative. Square root of 3 times square root of 3 would be what? Would be square root of 9. What is square root of 9? So after multiplying that out, the only radicals we have in the denominator are the 5 square root of 3 and negative 5 square root of 3, yes? But what is negative 5 square root of 3 plus 5 square root of 3? 0. Guys, are there any radicals left in the bottom of the fraction? No. Now we can combine like terms. There's no like terms to combine on top. But on bottom, 25 minus 3 is? And that's it. Questions on any of this here? Let's look at the next one. So we have 1 over the square root of 7 minus 2. So what will we need to multiply the top and bottom of this by? Yes. So we need to multiply the top and bottom of this fraction by the square root of 7 plus 2, because we're just changing the sign in the middle. Now the numerator, we can multiply the 1 through. 1 times the square root of 7 is 1 times 2 is 2. In the denominator, we have to multiply this out. Square root of 7 times square root of 7 is 7. We could do that in a calculator. Square root of 7 times square root of 7 is 7. Square root of 7 times 2 is plus 2 square root of 7. Questions? Negative 2 times square root of 7 is negative 2 square root of 7. And lastly, negative 2 times 2 is negative 4. Now the numerator. We can combine like terms, but that's still just going to be the square root of 7 plus 2. The denominator, 2 square root of 7 minus 2 square root of 7 is 0. 7 minus 4 is 3. So we get this here. Any questions on any of this here so far? Are you ready for the next one? Now, what are we going to multiply the top and bottom of this by? Yes. negative 5 plus 3 square root of 3, because we're just changing the sign in the middle. Now this time when we multiply the numerator through, we're not going to just get back what we have multiplied by it, because it's not 1. 5 times negative 5 is 5 times 3 square root of 3 is going to be plus 15 square root of 3. Because we only multiply inside the radicals if we have like radicals being multiplied, same index. Now we can multiply through the denominator. Negative 5 times negative 5 is positive 25. Negative 5 times 3 square root of 3 would be negative root of 3. Negative 3 square root of 3 times negative 5. Well, the negative and negative would make a positive. 5 times 3 is square root of 3. Negative 3 square root of 3 times 3 square root of 3. Well, the negative times a positive is a negative. But now we need to multiply. Guys. Three square root of 3 times 3 square root of 3, which is 27. Now in the denominator, our 15 square root of 3 and negative 15 square root of 3 will cancel out and become 0. The numerator is still going to be negative 25 plus 15 square root of 3. In the denominator, 25 minus 27 is now we can take this negative and remove it from the denominator and apply it to the numerator. The reason we'll do this is because it will give us a positive denominator, and it's going to change the signs of the numerator. So the 25 will become, and the 15 square root of 3 will be negative. Because if we can keep the denominator positive, we're going to do that. Any questions over any of this here? Let's look at one more before we are finished for today. So the last one we'll look at. This one doesn't look too bad. Let's look at this one here. 4 over the square root of 2 minus 5 square root of 3. So what would we multiply top and bottom by? Square root of 2 plus 5 square root of 3, yes? So if we looked at the last one we just did, 5 over negative 5 minus 3 square root of 3, we got negative 15 square root of 3 plus 25 over 2. We got the same thing, except we had 25 minus 15 square root of 3. Or the one we did before that. 7 minus 2 was 2 plus the square root of 7 over 3. Or 5 minus the square root of 3 over 22. And that is it. So your homework is on page 232. 14, 15, 18, 20, 22 through 28 even, and 31 through 34 is the entire assignment.